Welcome to the first video of our Class 20 series of lecture videos. We have seen Grignards formed at sp3 hybridized carbons. For example, if we took one bromobutane, we threw in magnesium, it would insert between carbon 1 and the bromine of our one bromobutane to give us butyl magnesium bromide. You could draw it with a polar covalent bond between the carbon and the magnesium, or you could represent it in the ionic form where we have the butyl anion with magnesium 2 plus and a bromide anion. Where does this lone pair of electrons on the butyl anion reside? Well, it's really in an sp3 hybrid-like orbital on our carbon. And how about Grignards at sp2 hybridized carbons? Well, we could have bromobenzene. We could throw in magnesium. Again, the magnesium would insert between the carbon and the bromine bond to give us phenyl magnesium bromide. We could represent that with a polar covalent bond between magnesium and carbon, or we could represent it in an ionic form. That lone pair of electrons is in an sp2 hybrid-like orbital. It's in the plane of the page, just like where the hydrogens that have not explicitly been drawn would be. And of course, we have the magnesium 2 plus cation and the bromide anion. How would we use such a phenyl magnesium bromide Grignard? Well, let's review our retrosynthetic analysis and do a problem. Say we wanted to synthesize trityl chloride, so triphenyl methane chloride. How would we do that? Well, we could synthesize the triphenyl methyl chloride from triphenyl methanol simply by adding HCl. That would be an SN1-like reaction. Ultimately, we want to work our way back to benzaldehyde and bromobenzene. Well, how would we get our triphenyl methanol? Through the reaction of our phenyl magnesium bromide with benzophenone. How would we get our phenyl magnesium bromide? That would be throwing magnesium in with bromobenzene. How would we get our benzophenone? Well, we could buy it, or we could oxidize this secondary alcohol. How would we get that particular secondary alcohol? Well, it would be a Grignard reaction of phenyl magnesium bromide with benzaldehyde, followed by aqueous acidic workup. And so we've done our retrosynthetic analysis. What would the forward direction look like? The forward direction would look like, well, we would take our benzaldehyde, add in phenyl magnesium bromide, followed by aqueous acidic workup to get to our secondary alcohol. We could throw in PCC, doesn't really matter about the water, to oxidize our secondary alcohol to benzophenone. Then treat it in one step with phenyl magnesium bromide, followed by aqueous acidic workup to get to triphenyl methanol. Then all we would have to do is add in concentrated HCl, and this would be an SN1 to trityl chloride. Of course, we would have to make our Grignard, and that would be the reaction of bromobenzene with magnesium to give us our phenyl magnesium bromide. We could alternatively have substituted in phenyl lithium anywhere that we use phenyl magnesium bromide. How would we make that? We'd just add lithium to our bromobenzene, and we would get phenyl lithium and a little lithium bromide. Sometimes we abbreviate that phenyl group as a pH, so bromobenzene would be abbreviated as PHBr, and that's an easier way to write it out. That concludes this first video. I'll see you for the next one.